Thank you for listening to the Maker in the Mix podcast, where we discuss design, innovation, and all things concrete.
Good morning, everyone. Welcome to a later morning edition of the Maker in the Mix. I had a dentist appointment this morning, so we moved the recording to later. So if you were planning on joining us live, apologies. But yeah, here we are. So Jeff was just telling me about making a hollow truncated cone in 3D software for 3D printing.
Good morning, everybody. I'm still learning real CAD software. Like, I don't have Fusion 360 yet, but I'm using Onshape, which is an online free version that's very similar to it. And so I'm still learning the ins and outs of it. So I'm actually 3D printing a flow cone right now for testing the slump of mixes. And so had success. Now I just have to make sure it actually prints. It's going to be 16 hours before it's done. So it'll be a while.
Oh my gosh, what's the size of it?
Well, it's not big, but I'm doing extra thick walls because I need to sand and make the interior really smooth. So it's just like, lots of layers, fine layer. Yeah, it's not a very big thing, but it's just dense. And I'm sure there's plenty of things I can optimize. I just let the slicer do its thing and increase the wall thickness, and that was it.
Yeah, I did. I just recently changed from a filament printer to a resin-based printer. I got an Elegoo Saturn, and I've been, super impressed with the results. My monitor actually is sitting on its stands, and I confess this is a piece that I broke when trying to get it off the platform. But you can see the print quality. This is just straight off the printer.
Yeah.
Just a little wild. So
I have a filament printer, so I'm not going to get that kind of quality. But
right, you did get some really good quality for the knockouts of that table we did.
Yes, I did. Yeah, and I did nothing to those, so I don't anticipate having to do very much.
It's very, very impressive.
Pretty happy.
Yeah, love that.
As a modeling tool. So I was going to say,
I've used it
as a tool for, building parts for molds, because that's what we did, use 3D prints as blockouts, custom shaped blockouts for that, the big table that you're sitting at. But just in general, it's kind of a cool new tool in the toolbox.
Oh, for sure. I love using 3D printers. And I've got, I've got some parts and pieces I've made, like a camera holder for my phone, because I don't know if I've mentioned this on the podcast before, but my webcam on my computer got scratched by, I assume, a sand grain that I closed my computer on. So it works still, but it's tragically bad. So I'm using my phone as a camera, and so I've got a little tiny mount that sits on my computer to hold it, which is great. And then
so it's basically
a number of things.
It's an iPhone webcam.
Basically what?
It's an iPhone webcam. Yeah.
It is. It's like a ridiculously expensive webcam, but here we are. No, it works great. Yeah. So before we jump in, a couple of things. So we announced publicly in an email blast, as well as I threw it into the big Facebook group, the Concrete Countertops Furniture and Artwork group. But I am now I've jumped into CCI as a part owner, so we're super excited about that.
Caleb's
so,
now
Jeff, you want to
official.
Talk about that a little bit? Minute? I'm official.
Yeah, sure. So Lane and I have owned CCI since the beginning, since 2004, and over the years she's wanted to kind of get out of that and sort of retire and get her fingers out of running CCI, because it's really my thing. And so over the years, we were kind of looking for somebody to kind of step into her shoes. And many years ago, when Caleb came to class, that was 10 years ago. We saw some really good things, and over the years, we started, training with Caleb and kind of getting to know him as a person, getting to know him as how he runs his business, how he runs his life, and his personal qualities and his personal values are right in line with ours. And so the time was right, and Caleb's now stepping into taking over all of Lane's roles as a marketer, promoter, co-trainer. And we got some really good ideas about where we want to go. I mean, CCI's role is not changing. My role is not changing. Our vision for what we do and where this industry is going has not changed. CCI has always been and always will be about high integrity, absolute honesty, and truth in the information we provide. And the truth and the information we provide is based on outside industry information from the engineering world, from the chemistry world, from physics. We don't dabble in smoke and mirrors and emotional manipulation or anything like that. We are here to support you, to build your success, and we want to be partners in your journey on that. And so Caleb has really shown his capabilities to do that. And I think this is going to be a very, very positive thing for us. And so we want to welcome as many people as possible into our community. And it's not a CCI community. This is the community of the concrete world. Because I know people, I have students all over the world, and our visions for what we want to do, what we want to create, our passions are all the same. And it's not about making me feel bigger or more popular or whatever. It's about you. And we're here, Caleb and I are here to support you. Whether you have no interest in buying anything from us, if you just want to talk to us, that's what we're here for. This podcast that we've started is here to just connect with you on a personal level so that you get to know us. It's, when you only are on an online forum or a Facebook group or something like that, the impression you have of people through text and through photos of their work is only a small fraction of who they really are as a person and who their business is. And this is another way that we can, reach out and let you know who we are as people. Because when you sit across from somebody, and here you're doing this virtually, if you were here watching us live, it's live. You're probably going to be watching this later on through one of the streaming services. You get to know us as people. You get to see us, and although it's not a true face-to-face, there's something to be said about hearing somebody's voice and seeing their face and matching their words to their actions. And so we want you to be comfortable with us as people and as leaders in this industry, because all of us are going to fail if we try to do everything independently and are selfish about only promoting ourselves. But we're all going to succeed if we work together and share together. And that's what we are here for. So
yeah,
everybody say welcome to Caleb.
Well, thank you, Jeff, for that. I appreciate that. Yeah, I mean, I again took the CCI Ultimate course October of 2013. So this year, October will be 10 years since I took the class. Just had 11 years since I started my company. Well, since I bought the company, I didn't start it. I guess you could say I started my company in 2020 because I changed the name to Lawson Design in 2020. But yeah, I have been. I mean, as you may have seen, you may know, like super passionate about CCI's mission and the way that Jeff, runs classes, the way that you teach, the basis from which you teach. I've always been very drawn to. As Jeff mentioned, we don't teach from the. I mean, yes, there's a lot of experience here, right? But I think, Jeff, you said to me the other day that experience. What was it? You really need experience. You really need experience after you or before you gain it. It's the wisdom that you gain from experience. You actually need that before you gain the experience. And so, I think that the bent of CCI to provide kind of the foundational experience, it's always great to. That's why you learn from professors, or you do a mentorship, or you got an apprenticeship. It's like you're trying to gain experience without going through the hardship of gaining experience the hard way.
The quote, and this is
and so I'm really excited.
It's some silly meme. It says it's a plane crash, and it says experience is something you don't get until just after you need it. And that's a little bit of a snarky, twisty thing. But yeah, like if you're going to fly a plane, you go to flight school, right? You just don't hop in a plane with your buddy and go, "Hey, let's go." That's cool if you're going to run
in the world, Rolls Royce and all this, but
that might be cool for like riding around in a go-kart in your backyard. But if you're going to like do something serious, learn from people who have credentials, who are serious. So that's where we're coming from. Like that's why I have all these things.
I think that's and I think that's why I really, my dad's an attorney, and I've always gravitated very heavily towards the analytical, logistical, logical side of things. And so I think there's a value in the emotional side of things. I mean, concrete as a material, as we as artisans know, is a super evocative thing. I think there's a lot of emotion tied to the types of things, but the reality is it's a medium. And what we want to help you do is to understand your medium. It'd be kind of like, I'm going to become an oil painter, but I don't know the characteristics of oil paint. It takes a long time to dry and things of that nature. So, I think that is why, I have so loved being a part of CCI from a kind of an ancillary point of view, from, assisting with classes at first. I think that was in 2018. I started doing that. And then I've done that, did that a few times. And then in 2019, I hosted an alumni event at my studio, which led to hosting an ultimate class at my studio. And that kind of started the classes are held at Lawson Design kind of thing. And so it was definitely an evolution of roles. And so, I mean, it almost seems like this is the natural progression of the partnership to me.
It is.
And I'm super excited. We have a lot of things kind of coming down the pipes that we're stoked about. So be paying attention, because there's going to be a lot of really good stuff coming out that Jeff and I are really
CCI
actively working on. No, not at all. So yeah, I just wanted to jump in and kind of give that little update to the audience at large, if you will. It was funny. I just did that hand gesture, and which was semi-jazz hands. And last week, Jay, my shop foreman, he saw me kind of editing the podcast, and he was like, "That's your hook. You need to just have a GIF or a GIF of Caleb doing jazz hands."
Jazz hands.
So maybe that's our new. Yeah, I don't know, but yeah, so those of you who are in the industry and have kind of been seeing me be a lot more active in the CCI kind of realm on the big Facebook group, on the CCI alumni Facebook group, that's why. And
That's
so I
why.
want you to know that I'm available to chat. I'm available to talk to y'all and kind of be support, whether it's technical or business. Really, that's something that CCI has always offered, and I just, my kind of personal aim is to kind of bring that out into the forefront.
Yeah.
So
this is all part of us getting to know you and you getting to know us.
Yes, absolutely. Yeah. And so today, the title of our podcast is yet to be determined, but it'll be something to do with exterior concrete, whether it's countertops, fire features, water features, whatever that might be. So Jeff and I really wanted to talk about the bones of outdoor concrete. So a couple of things I want to touch on before we get going, Jeff, so that we've got some outline points are the benefits of a CSA-based cement in salty or chlorinated environments. I think that's huge. Talking about, certainly we've touched on sealer a number of times, curing, just getting pieces outside that are going to last outside. Coming from Florida, I certainly did a ton of exterior concrete. So I wanted to touch on a lot of those things. And then, one thing that we have not done a ton of is talk about our products on the podcast. And while I do not want this to be an infomercial, that's not, I can't stand infomercials. I'm not going to be, who's the guy that did OxyClean forever? Anyway, we don't want to do that.
Mays.
Huh?
Billy Mays? Was that his name?
Yes, Billy Mays. Memorable though he is, we want to be a lot more personal than that. So I just posted on the CCI alumni Facebook group. If you're a part of that, I was like, all right, seal a discussion time. And the kind of rules that I put in place for that are, we're not going to bash people for what they use. So, we have expertise beyond our own products. If you have a question or a technical issue with your products, reach out to us. I guarantee you we've probably tried it. So, so with that, let's jump into concrete for outdoor kitchens and outdoor elements.
So,
so what do you think
every time I start, I always have to start from the basics as a point of progression to give context as to where we're going to go. And when you think about it, almost all concrete in the world is exterior concrete. Sidewalks, roads, bridges, buildings, parking garages, that sort of thing, outdoor concrete. So we're not going to talk so much about that kind of concrete, where you really have to be sensitive about your cement content, how many sacks of cement are in your mix, or air entraining agents and things like that, because that kind of concrete, to be kind of blunt and judgmental, is ordinary, plain Jane, okay, but not fantastic. The kind of concrete we work with, and there are a lot of people that use a lot of different mixes, but they're all relatively similar in the sense that they have very, very great properties. Especially if you're using concrete that has polymer in it. You do not need air. You don't use air entraining agents. It's not an issue. Even just high cement content mixes are very, very weather resistant, freeze thaw resistant, that sort of thing. But when we get down to the nitty gritty and start thinking about what kind of concrete we make and what are our customers needing out of our concrete, the preservation of that high surface quality, the integrity of the castings, the durability of the product over time from weathering and things like that. Those factors, that's what we're going to be talking about, right? So one of the things you had mentioned, Caleb, was CSA cements and seawater. So anytime you're near the ocean where you have seawater or salt spray, if you've noticed, ordinary concrete tends to degrade right? It crumbles, it spalls, looks nasty over time. And that's because the sulfates, seawater has a lot of sulfates in it, and the sulfates attack the concrete. There are some natural ground deposits that have sulfate in them, and that's why there's like a type 2 cement and there's actually a type 5 cement, which you can't get. But like a type 2 cement is a moderate sulfate resistant cement. So if you were casting a footing in the ground and your ground has some sulfates in it, and some parts of the country do, and other parts of the world do too, you'd use a type 2. And by and large, well, this is gray cement we're talking about, because there's no such, as far as I know, there's no such thing as a type 2 white cement. You just don't do that, right? Why would you use white cement for footing in the ground? But all that being said is Portland cement, if it's just a normal type 1 or GP or GU, general use or general purpose cement, is susceptible to sulfate attack. And seawater has a lot of sulfates, as I said. So your concrete is going to be more prone to that. Now, some pozzolans can help with that, help reduce that. So it is possible to make a more sulfate resistant concrete using the right cocktail of pozzolans and low water cement ratio and all that. But if you use CSA cement, like Rapid Set CSA cement, which is the Bellite form of it, that is very, very sulfate resistant because the basic chemistry is basically unaffected by sulfate attack. So it's equivalent to like a type 5 cement. So if you are casting anything near the ocean, you might want to consider using that for long-term longevity. Now, sulfate resistance is not the same thing as acid resistant, because there's so many different kinds of acids that start to chemically degrade the concrete. We're talking about something different. So this is just a point I wanted to bring up.
Let me question on that, on the CSA and sulfates. Now, if I understand correctly, and do correct me if I'm wrong, it's also resistant to a chlorine type attack as well. So the application I'm thinking of is like a chair or table in a pool or something, a pool bar kind of situation. As well
possibly.
As being by the ocean. I mean, I wanted to talk about that too. So I'm just curious on that, if you know what.
Most concrete, it's not the concrete that chlorides affect so much as if you have steel reinforcing in it. That's where the problem happens. Like steel, chloride intrusion in concrete is a bad thing, because it really accelerates the corrosion of steel. Well, most of the time we don't use any steel at all, ever. Because we're either using glass fibers or synthetic fibers or fiberglass or basalt rebar or some non-corrosion prone reinforcing material. That's not super much of an issue. But yeah, who knows what else is in a swimming pool. So, and sealers.
I think exterior things, I think CSA is a really nice.
It's a good, safe choice to use. And the fact that for a lot of us, it's so readily available. You go to Home Depot and you buy it. There you go. So it's not the only answer. It's a very good, easy to get answer that also happens to be really easy to work with. It's one of my favorite, commercial bag mixes is, when it's $25 for a 55-pound bag, you really can't go wrong with that.
Yeah. And that's going to lead us down the road of cost discussion here in a minute, I think. So let's keep that in the back of our minds, because I think that would be an important thing.
Yeah, we can come back to that. So I mentioned air entraining agents and freeze thaw. So normally, I'll get questions from folks about, I live in Canada, it gets super cold, or I live in Minnesota and it gets super cold. It's not the temperature that matters so much as the transition from freezing to thawing. That's the problem. So if your concrete only freezes once a year, okay, it only has to withstand one freeze thaw cycle. Well, like here in North Carolina, in the winter, we get lots of freeze thaw cycles because it might freeze overnight and thaw in the day. So we might have 30, 40, 50 freeze thaw cycles a year. Which is a lot more stressful on concrete, because it's the expansion of the water. Not, once water freezes, that expansion's done. It's already frozen. So it's that change that's the problem. And really high performance concrete, like what we make or what we should be making, is nothing's immune to it, but it's very, very, very resistant to it. So much so that it's not even something we have to think about. So it's, if you come from the world of using conventional truck-based mix where you do have to think about air and training, once you step into this world and start using a different kind of concrete, it's not an issue at all. So rest assured, what we have to all focus on, and I know you're going to agree with me on this, is not the cold, but the heat.
Yeah.
That's where a lot of the problems come from.
Yeah. So on the air and training thing, what we're really after is majorly mega deep or mega dense concrete. Because getting that air to X-train, if you will, getting that air out is so that kind of leads me to a really interesting thing that I kind of experimented with earlier this week. So as Jeff obviously knows, and others know as well, I have been using our line of Alpha Pro products, the polymer, the fluidizer, plasticizer, and the defoamer, which I haven't had as much of a need for the defoamer, honestly, because my concrete is not super foamy. There's a kind of a misconception out there that all polymer creates foam, which is not true. And so anyway, I did a very interesting kind of case study in my shop last week. I cast 6 samples, 3 colors. So kind of an A/B per color of those 3 colors. 2 were CSA based and 1 was Portland based. And the A/B test was very simply Alpha Pro Polymer with in one and no polymer at all in the other. And I really ought to do a third test with Forton just out of curiosity. But what I kind of came out with, which was really interesting, was with the exact same in the CSA cement samples, the cement all, the results were both poured basically the same. They felt no different in casting. There's no stickiness like you get with a liquid polymer. And these had no fibers in them. So that's a totally different thing. But they both poured identically. They leveled out identically. The interesting thing was that the polymer sample was a little bit more color enhanced. So it was a little darker, a little more vibrant color-wise, and then the no polymer sample. And then the second thing that was very noticeable was the amount of pinholes in the no polymer sample. So the polymer sample had, 1% maybe of the pinholes that the no polymer sample had. We're talking about a difference of night and day. And that was across the board. And then on the Portland sample, this was interesting. The polymer sample, polymer modified sample, I did not use enough fluidizer. I'm at a 0.29 water cement ratio in Portland, a 0.35 in Cementol, which is the minimum. And the Portland sample, I didn't use enough fluidizer, and I had to really manipulate it to get it to go, into the form. I had to almost hand press it. It was a little more non-Newtonian than that, but not fluid at all. The not polymer modified sample, I added a little more fluidizer and it self-leveled, no problem. The interesting thing was when I flipped them the next day, there were 0 pinholes in the polymer sample that I had to press in, and there were pinholes galore in the non-polymer sample I poured. And that's been my experience since changing to Alpha Pro in general, is that I can direct cast backer, GFRC backer with 3% fibers, and have a virtually pinhole-free face. So that's something that I've been really, really impressed by. And, we talk a lot about surface quality and air entrainment. If you've got a lot of pinholes on your surface, there's a lot of opportunities for stuff to get in and stain under your sealer.
Pinholes are the chimneys that They are no different than like a deep scratch or a gouge or a chip. They're conduits into your concrete, and very few, well, no real sealers that perform well other than like a thick bar top epoxy coating cover
Great.
tiny pinholes. Tiny ones that you can barely see, those are the worst because the surface tension of the liquid holds it back from the pinhole. So little pinholes, some people call them pinners, are kind of the bane of our existence, and they're a challenge. So anything that you can do to make your concrete not have them is a good thing.
Yeah. So I mean,
Oh,
I've gotten to the point now where I rarely grout unless the finish requires it. I mean, it's wonderful.
right. I want to
Um,
kind of step back and talk a little bit about polymer because you're going to hear online in groups and things like that some people swear at polymers. They vilify them. They're like, oh, I don't need them. You don't need them, or they're they're bad for your concrete, or they weaken the concrete, or they slow things down, or whatever, right? And some of those characteristics are true, but they're true for specific types of polymers. So it's kind of like saying, like, I'm going to make a little analogy. Way back when I first got started making concrete about 23 years ago and selling it, I had a husband and wife come in, and my showroom was my kitchen, and we were talking about their project, and they said, and I may have mentioned this story in the past, they asked how, we've read that concrete stains, right? So concrete, they're lumping all concrete into one category and saying all concrete stains, all concrete cracks, it's all bad. And I said, that may be true for a specific piece of concrete made by a specific person, but mine doesn't, right? So it's different, and it's the same could be said for true of polymers. Yeah, I mean, over on my bookcase right there, I'm not going to get it because I have a dog on my lap right now, and I don't want to disturb him. It's raining, and he doesn't like the rain. I have a book on polymers in concrete, right? There are lots and lots of polymers in concrete. There's not just, SBRs and EVAs and acrylics and PVA and all that, right? So there's a lot of different kinds of polymer. GFRC and curing polymers are only acrylics. They're some of the most expensive ones, and which is another reason why a lot of people don't use them, because they're trying to be cheap and just save a penny by not using a good product to make their concrete better, which I think
that's
is,
going to lead us right back to that same point of conversation here in a minute.
Yep, penny wise and pound foolish, but we'll come back to that. So when GFRC became a commercially viable product in the 70s, let's say, it was a spectrum of years, but let's say it's in the 70s, it was a curing polymer that made it commercially viable, because then you did not need to do a full 7-day wet cure of your pieces before you then could install them. And we're talking like thousands and thousands of square feet of building panels all at once, right? So you need a big climate control warehouse. It gets very expensive. The role of polymer is to eliminate that from being needed. So you can cast today, demold, let it air cure, and it still will continue to gain strength because the polymer is holding moisture in the concrete. That's its role. That's its job. And the only polymers at the time that were commercially available were liquid polymers. Forton being one, Polycure, Polyplex. Those are three that I've used over the, Polycure's over in the UK, Polyplex and Forton here in the United States. Forton's elsewhere too. But these are all liquid polymers. So they are white, high solids, usually around 50% solids. And they all share similar characteristics. Their main job is to hold moisture in the concrete, and they do a really good job at that. But one of their side effects is they tend to make your concrete pretty foamy. And if you think about how commercial GFRC is made, it's almost always pumped and sprayed through a big sprayer. And it's the spraying action that purges a lot of that air. Well, if you take that machine away, and we're not just talking about the mist coat, but you're also spraying the backer too. So that action of spraying helps purge some of that entrapped air. Well, If you take that away and you are only pouring your concrete, there's no action to get rid of that air. And because the polymer kind of creates a stable foam, even if you're trying to vibrate the concrete, that foam doesn't break up and let the air disperse. So these kind of polymers tend to make foamier concrete that, if you're not doing something to get rid of it, you tend to make less dense concrete. It's physically less dense, and there's a lot more entrapped air in it, which leads to slightly lower strengths.
And really, that's not about the lower strength of the physical material. It's about the less,
it's the absence of material,
less
the
material.
air. Yeah. So if you have a block of concrete and you measure it really carefully and then you weigh it, you get a bulk density. And if you do that to different concrete samples, and we're talking like measured to the thousandth of an inch, so you want to be really, you need good geometry and good measurements, and then you can get a pretty good accurate sense of the bulk density. And
what would be
every time you do
in the numbers, like
you're going to hear numbers tossed around which are based on different things. Like, so I'm talking in imperial units here. So normal concrete's typically the bulk density is considered to be 150 pounds a cubic foot. Well, that's a rough average because a lot of it depends on the aggregates. And if you think about regular concrete, most of it is made up of rocks and sand, right? So if all your rocks are made and all your sand is made of quartz or silica based minerals, they all have a specific gravity that's about the same, which is pretty predictable, around a 2.65, 2.6, 2.7, somewhere in that range. And then the bulk density of cement is known. The bulk density of water is known. So if you know all the bulk densities of all the ingredients and you know how much you're using, you can calculate how much it should be theoretically. But because when we mix concrete, we're in an atmosphere, right? Air is always mixed into our concrete. We can never get all the air out. So the more air that's in the concrete, the lighter it is, the fluffier it is. And the goal of all concrete, if you are casting a wall and you put that vibration stringer down there, what you're trying to do is not have honeycomb. You're trying to work that air out, that big excess air out. So we want to fill as much concrete in our forms as possible because that's where our strength's coming from. And if you have an ingredient that creates foam, that basically is dispersing that air into small, tiny bubbles and trapping it. It can't leave. So the more air that's in your concrete, the lighter it weighs, but there's less concrete there in that space, so it becomes weaker. Which is, here's a tangential note. If you're trying to make really, really lightweight concrete by putting foam into it, whether that's styrofoam or perlite or whatever, you're just putting voids in the concrete and taking away you're going to make weaker concrete. That's just the nature of the beast. So that come back on this track. So when I developed Alpha a couple of years ago, I wanted a dry polymer. It's not the only dry polymer. There's other ones out there. But I wanted a dry polymer that was economically competitive with liquid polymers, but would give better performance. And it measurably does. So you don't have to use an expensive liquid polymer that, you can't let it freeze and things like that. And also have to struggle with it being sticky. And then you have to also struggle with it gets moldy or it gets chunky and stuff like that. And also they tend to make your concrete foamy, which you struggle with. And so that's why a lot of people don't use them, because they're, you start to sacrifice the quality of your concrete because you're trapped in this, using this material that in a way that was never intended to be. Again, commercial GFRC is sprayed. And if you're not spraying it, you're not making the concrete the way it was designed to. So with Alpha, you can get very, very high densities because it has, it's not sticky. Like it is an acrylic polymer, but it doesn't have that sticky characteristic to it. And it has a very, very powerful defoamer in it built into it, so that air comes out as you're mixing it. It doesn't create a foam. So you get much denser concrete, you get better surface quality. And so the characteristics you're seeing, Caleb, of being able to direct cast and not have pinholes is absolutely
Consequently,
true.
also not have fiber showing, which is nice.
Right. Yeah. And they kind of go hand in hand in a way. So like, yes, I've been doing some tests with Cementol, because there are a lot of people who use Cementol and don't use a polymer. They're like, well, I don't need it. Okay, great. But I can make your Cementol even better than what you're making now. And so I'm doing flexural tests. In fact, this afternoon I made some samples yesterday. I'm doing 1-day tests on these, and I'm going to be comparing Cementol, same bag, same water cement ratio, same fiber content, with Alpha and without, and run them side by side. I already did it on some older Cementol from a year and a half ago, and I got some interesting results. Yep. The results being the samples with Alpha were 25% stronger the next day by just adding that. And you would think, oh, well, it's going to make my concrete. No, it flowed better. It cast better. It tested stronger.
Yeah, I mean, I know there's some pretty adamant voices against polymer, which is interesting to me because, it seems to me, and this is just me being a totally logical brain, but it seems to me that in an industry like PCI, right? They and their cohorts and the industry at large is doing billions of dollars of research, and to make sure that because their bottom lines, I mean, when you're doing a multi-million-dollar project, your bottom line matters a lot. A penny matters a lot. And so, they're doing these flexural tests and these strength tests and these materials tests. And so, if there was a better alternative to a polymer, they would have found it by now.
Absolutely. Absolutely.
And maybe one day there will be some sort of synthetics alternative. I'm not sure. But, it seems to me that if that wasn't the best way to achieve extremely high strength concrete, extremely resistant to, your curing techniques are fast. So high strength, fast, economical, they would have found it and they would have done something different. And now that's, again, not to say that technologies don't evolve, but we have not gotten there yet.
It's when you have, how many research institutes are there around the world?
Lots.
Hundreds, thousands of very smart people. And you look at what is their common message about curing concrete and the methods, especially when, think about what we're making. I'm going to grab a prop here.
Jeff likes props.
So I love my props, my little notepad. I got tons of these. We're casting a countertop, a wall panel, a table, a piece of furniture, whatever, right? We're casting something, lots of surface area, not a lot of thickness. Like maybe you're casting a wall panel that's half an inch thick, okay? But it's, several feet on a side. Lots of surface area, both top and bottom, for the moisture in that concrete to evaporate. And if your concrete loses moisture, there's a threshold below which it stops chemically reacting. So it's not really gaining a ton of strength. It's certainly not giving you the strength you think you're getting or you're being told you're getting. The only way concrete gains strength is if it has the moisture to keep that reaction going. And curing, the whole notion of curing, keeping it wet, keeping it covered, whatever, using curing polymers, its job is to hold up moisture in. It's the moisture that's doing the job. And when you make concrete, and this kind of blew my mind when I was younger, and this is the first time somebody told me this. When you mix concrete and you put the water in the mixer and you mix it up, that water is all the water that concrete will ever need forever. And all curing does is keep that in there. You don't put water back in the concrete. If you're having to put water back in your concrete after it's hard, you did something wrong. It's holding it in there. It's keeping it in there. What were you going to say, Caleb?
Yeah. So, curing practices, and I know that we're on the topic of outdoor concrete, and I do want to get back to that, but this is very important, I think, to making high quality outdoor concrete. So your curing practices, is it enough? I think there's a lot of maybe misunderstanding in the industry about curing practices, because we all cover our concrete. I use just plastic most of the time. I know you've been using some moving blankets lately. Others use heating blankets. Certainly in the winter, I keep my heat on, and that's radiant. And so there are definitely, in addition to the covering it and things like that. My question is plastic enough?
So that's a good question.
Without polymer, I should say, really is the.
Well, that's
the question I'm asking.
Again, the role of polymer is to keep moisture in your concrete.
Yes.
Forever. It's not. It doesn't make it waterproof. It doesn't make it stain proof. It doesn't stop the water from evaporating.
And it also doesn't make it. It doesn't make it take on the characteristics or properties of the polymer.
No, there's not enough in there.
Right.
Sure, if you start adding a ton of polymer, it's going to make the concrete not rubbery. It never does that, but a little bit more flexible. But like with Alpha, our solids dose, because since it's a powder, it's 100% solids, right? There's no liquid. We're only using a 3.5% dose. So 4-ton, minimum's 5%. The commercial industry actually uses 6%. Yeah. And then I've seen recommendations for 7% or more for certain applications. We don't have to go there. We don't need to be that high. We don't need to like double the polymer just to get the kind of properties we want or what we're getting. But like when you said you cover your pieces overnight with plastic, I do too. That's good practice. And the reason for that, the reason why you cover your freshly pieces of concrete with plastic is it takes a while. It generally takes, I'm going to wave my hands here, 16, 18, 20 hours for that polymer to fully coalesce and start to do its thing in your concrete, right? It's not instant. It takes some time. So while that's happening, your concrete is vulnerable to losing that precious moisture. And remember, your concrete is the most fragile, the most vulnerable, the most weak right after casting. It's like you just broke a bone. You got to let it heal. Well, if you broke a bone and put a cast on it, would you take the cast off the next day? No. And then start using it? No, you got to leave that cast on long enough for the bone to heal, and then it's strong. That's kind of, that's rough, that's a weird analogy here, but like if you cast your concrete, and especially if you're foolish enough not to use polymer, and I'm getting on a soapbox here and being a little, preachy here. If you don't use polymer and you don't cover it in plastic, you're an absolute fool, because your concrete losing moisture, it's not curing properly. You're going to have shrinkage issues. You're going to have cracking issues. And maybe it's not right now, but down the line, it will, because you're sacrificing the quality of your concrete for what? A few pennies? Really? We want to make concrete that lasts a long time. My goal for all the customers I've ever had, and for all my students who are my customers, is I want you to have happy customers that you never hear from again. Because the only time you ever hear from customers, mostly, is when they complain about a problem. And that problem usually happens because you did something wrong. You created a situation that created a problem down the line. Now, this is, again, kind of preachy, but this is what I've seen from, near over 20 years of teaching people and helping people with troubles. Most troubles come from the manufacturer of the product, or the choices that go into using too much water, or the wrong this, or whatever, right? Coming back down, curing is a process of creating conditions that allow the concrete, the chemical reaction, to continue so that you get to certain physical properties, strength, durability, low permeability, low porosity, stability, it doesn't shrink and curl and things like that. You want to get to that point. And if in conventional concrete, because you're casting such a thick layer, it's got a lot of internal moisture, and we don't really care too much about the quality of the concrete. So, we'll strip the forms quickly and just let it sit out in the sun or whatever. Well, if you're casting something thin, it's going to dry out really fast because there's a lot of surface and not a lot of volume. So we have to really pay attention to maintaining those early days, that first, say, week. The first 7 days are the critical to your concrete. Well, if I've got a curing polymer in there, all I need to do is cover it in plastic for one night, take it out, and now can be in the open air. That polymer's doing its job, and it's going to keep gaining strength and have properties that are so good at a week that I don't have to think about anything. And you're probably going to be sealing your concrete before then too, so that's even better. Now, if you don't cover it in plastic, it's not going to start curing right because water's going to be evaporating real fast before that polymer kicks in. And if you've noticed, you cover your piece in plastic overnight, you take the plastic off, what's on the underside of the plastic?
Water.
Condensation, right? That condensation is the water that's coming out of your concrete that would escape. But the plastic's trapping it and at least creating a humid environment to minimize how much is coming out. One thing I have noticed since developing Alpha and doing a lot of tests with it is samples that I cure under plastic have less condensation than samples that use Forton.
I've noticed that as well.
Have you noticed that too? That means it's doing its job even better than Forton earlier.
Lower dose, mind you.
At a lower dose. So
okay, so that's soapbox number one.
Yeah.
And again, and one of the reasons that we're talking about exterior concrete specifically is the environmental pressures for it to perform are so much higher. I mean, a lot of I did outdoor kitchens galore when I was in Florida, and I still do a fair amount of exterior stuff here. And the times that I would go and install something and it would get rained on the next day, or wasn't covered and in direct sunlight. I mean, I have clauses in my contract for I don't do dark colors in full exposure to the sun for safety reasons, really, but also they're more likely to have damage. And so these things you think about, but they are abused by just the factors of nature before you even use them. And so, especially in countertops, vertical surfaces, not quite as much, but, that's one of the reasons we wanted to focus on, and really it's best practices all the time, but they're critically important when you're doing exterior concrete. So, we want you to use the right ingredients. We want you to cure your pieces properly and treat them properly and then seal them properly. So I wanted to chat really fast, Jeff, about the properties of like a water-based breathable urethane versus a non-breathable, solvent-based finish.
Yeah, or like 100% solids epoxy.
Yeah.
With outdoor concrete, most of us are in an environment where it rains and there's humidity, right? You could be in the high desert somewhere where it's 6% humidity, and that's a slightly different story. But anywhere there's lots of humidity, your concrete is going to over the years absorb some moisture from the environment. And in the sun, right? So we're going to talk about, again, this is getting back to evaporation. Okay. If you seal your concrete with a very impervious coating and, gut your gut is going to say, I want to protect my concrete. I'm going to use something that doesn't let anything through it. It's bulletproof, right? Well, that works just fine indoors. But you go outside and you put an impervious coating over something that's got moisture in it. That sunlight is going to hit the concrete. It's going to warm it up. And as you mentioned, you don't make dark color concrete. Have you ever walked barefoot across a black parking lot, a blacktop parking lot?
It hurts.
You're going to burn your feet because it's hot. Dark colors absorb a lot of infrared light and get hot. Well, the hotter your concrete is, the more water vapor there is that is generated. So moisture in your concrete is turned to water vapor. Water vapor has a lot of pressure to it. And that vapor pressure wants to escape. You need that to go through your finish. That's what's meant by breathable. It's not about air. It's moisture vapor. It's water vapor. You want that water vapor to expel itself through the finish so that you don't have problems. Mm-hmm. Now, this is well known in floors. Like if you go into a concrete floor and somebody comes in and puts an epoxy coating on a floor that's moist or has ground, it doesn't have a vapor barrier underneath it, and groundwater can get in there, you'll get blistering.
Yeah.
And that's a big problem. And that's indoor flooring. So if you've got moisture vapor outside, you could have problems. And that may not show up the first season, but if you've got that cyclical pulse of vapor pressure that happens every day, every night cycle, all summer long, eventually something's going to give. And it's either the sealer pops or flakes. It depends on the properties of that. It could delaminate. It's like trying to push itself off the concrete because it's like a balloon, like water vapors pushing against that finish. And where is the concrete the hottest? On the surface that's sealed, that's exposed to the sun. So if you're using a finish that is not breathable, that doesn't let water vapor through it, you could be creating future problems that may not show up for a year or 2 or 3 years. And what does that translate to? Callbacks. And those are super expensive.
Mm-hmm.
So that's why I said I don't want to hear from a customer, because if I never hear from a customer forever, 10 years later, 15 years later, and I have products out there that are 20 years old, and I've never heard from a customer, that means I have 20 years of no callbacks. So I'm willing to spend a little bit more money up front as insurance against future very expensive headaches that come down the line.
Yeah,
and that's
absolutely
true of ingredients, true of sealers, true of practices, things like that.
Well, and I think having a reliable practice, reliable products, reliable sealers, and things like that have been around, long enough, which is hard in our industry because there are very few things that have been around a long time, right?
Right.
And certainly there are with it being a young industry, there are new materials being developed all the time. And so that's why we stress so heavily not trying things on your client's work. So I'm really adamant about testing a product separately and then adopting it as a use case study. Because we don't often have a lot of that data. And I think that data is scoffed at a lot. It's like, oh, well, I don't know what the argument is against data. I really don't understand that. But I think having
it's not opinion.
Exactly. It's not.
And
so, whether it's your sealer or your mix design or your, best practices, like make sure that those are viable and are working before you put them at a client's home or project. And that's just, it's not me being preachy. I mean, it's kind of preachy, but at the same time, it's like, we're trying to protect you. We're trying to, teach you how to swim. We're trying to, and rest assured, I've made every one of those mistakes. So it's not like I'm, coming from some high horse and be like, oh, you never do this because I never did it. No, I did it. I did all of it. And eventually, I think people are like, well, this is impervious. It will come back to bite you. And so I think that's why, having the best practices and exercising the best practices often evaluating them, making sure that you're kind of is kind of in the right spot is prudent.
It's good to innovate.
Yeah.
And it's good to advance. But I keep one foot very firmly, not in the past, but
In the proven.
on a foundation of solid, proven knowledge that other people who are smarter than me have generated. And I am taking that vast universe of information, interpreting it through my training and my background and my skills to make it appropriate for what I know what our needs are. And that's kind of the role of an expert, is really a translator.
Yeah.
And if you have so much hubris that you think you're smarter than everybody else because you have an answer that nobody else has come up with, you either are a genius or you're a fool. And unfortunately, there was a recent incident, very tragic incident, that the founder of this company ignored good industry practices and the advice of experts because he was smarter than everybody else and he had the answer that nobody else did. And unfortunately, some terrible things happened because of it. That's hubris. That's foolish. And no, nothing bad's as bad as that is going to happen with us. But we're all in business. We're all here to make a living, be creative, have happy customers. And there's a simple recipe for doing that. And the simple recipe is trust, test, validate, and have confidence in what you're doing. There was another, and I got distracted by myself and I forgot the other thing I was going to say. But don't make mistakes. Don't create problems. That's how you're successful. It sounds silly. It sounds very simple. And it sounds almost trite to say, oh yeah, everybody knows that. Don't make mistakes. Don't create problems. But you would be surprised at, and everybody does this, how many individual decisions you make. If you don't think 3-4 steps ahead, what are the implications of that? One time I was putting a form together and I put the sink knockout in backwards and I didn't catch it until we demolded. Had I done what I teach people to do, is say, okay, inspect your forms before you cast, because this is your last chance to catch a stupid mistake like that. I didn't do that because, oh, well, I either forgot about it or I got distracted or whatever. I mean, that's a process mistake, right? But that's a good example of something simple you can do that will save you money, save you time, save you headaches. And that never even got out of the shop because we corrected it.
Yeah.
But I know, let's say I go out there and I buy, I don't know, I think I'm going to be clever and I'm going to go buy some newfangled whatever sealer, Acme sealer that somebody is touting to be is the best thing in the world. And I don't test it. I don't validate it. I just go, oh, this guy, I like this guy. He's good friends with me on Facebook, and I'm all excited because, he wears the same kind of hats I would do, and we have tattoos and whatever. I'm going to do that too. And I do it on a big project. Maybe I get lucky with it this time, but maybe the next time the project's a little different, or something else is different that I didn't pay attention to, or I didn't know was important, because maybe the guy who is selling it to me doesn't really know what's important. He just wants to sell stuff, and I use it, and it comes back to bite me. And now I've got hundreds of square feet of concrete. I got to go back on a job site and spend days fixing. And now my reputation is affected and my customers mad. and maybe it's going to cost me hundreds or thousands of dollars to fix this. And in all this process, all the projects that I had going on are on hold because I gotta put out this fire. And this fire was created because I didn't do one thing. I didn't test the finish. I didn't validate it for myself. And that's what we're getting on about here. And as Caleb mentioned, we're going to come back to this. Outdoor environments are extremely challenging. Just think about the temperature swings from winter to summer. You could have 100,
depending on where you
day
are.
and night. Yeah, it's huge. You got sunlight exposure, you got rain, you got birds and leaves and all kinds of things. And all of you folks who do decorative concrete, especially outdoor, you know what this is. You know the challenges. And one thing that's going to be true is there is no finish that's permanent for outside. It doesn't matter what it is, you're going to have to reseal. It's just a matter of how often, right? So now part of that equation is how easy or difficult is that going to be? And if you look at like in the decorative concrete world, where let's take like a stamped patio, pretty common, right? Outside of our normal field of product, but a lot of folks do this. The most common finish for that is a solvent-based acrylic. Okay, those are terrible for countertops, by the way. Don't ever use those for countertops. They just don't perform well. But they're very good finishes for a patio. And one of the main reasons is they're kind of breathable, and you can
flash off fast, easy to reapply.
Flash off fast. You can recoat them because they're affected by solvents. So the solvent in the finish melts and dissolves the finish that's already there to kind of re-emulsify it. Great for maintenance, right? So that's where those products shine. The right product for the right application. I wouldn't, like I said, don't use like an epoxy. Don't use epoxy outside. Most epoxies will yellow, and when an epoxy yellows from sunlight, from the ultraviolet light, it's actually chemically burning. It's like you put a slice of bread in a toaster, it's toasts. What you're doing is you're burning it in a controlled way. And well, that's what's happening to your epoxy. So any kind of finish or any kind of product you use outside has to be UV stable, cannot be affected by sunlight. So use the wrong pigment, it could fade. Use the wrong polymer. There's some liquid polymers out there that will turn yellow. They're not curing polymers, they're bonding agents. Totally different. Typically SBRs or styrene butadiene rubbers. They will turn yellow in the sun. Don't use them. And they're not curing polymers, so don't use them.
I think the bottom line that we're kind of getting at here is that using exterior concrete is a similar but different animal. You have to be more prepared for the types of challenges that exterior
you froze up on me.
Exposure. I didn't in the recording, so
okay, that's good.
Yeah. You have to be prepared for the different types of exposure that exterior, elements bring to the equation.
Absolutely.
Long term too, so keeping that water in your concrete and having a polymer is long term a good thing. So we don't, so all of that to say, I think that, we're just preaching about best practices, but they are particularly important outside.
Yeah. Now, one thing that doesn't have to do with an ingredient or anything like that, but a general characteristic of concrete in general, like if you are used to working inside a house, you kind of have it easy. And I'm talking mainly from a temperature standpoint here. The internal swing temperature of a house generally is pretty small. For most people's houses, it might be 5 or 10 degrees. We're talking Fahrenheit, so centigrade would be like roughly half that. But let's say it's 20 degrees. Okay, that's a lot for inside. But for concrete, that's nothing. Right. And what I'm getting at is the bulk expansion contraction from thermal changes. So if you've got a piece of concrete that is outside, let's say you make a table and it's outside, it's just a slab. When it's hot, it's going to get bigger. when it gets cold, it's going to shrink. And that's just going to happen over the course of a day, over the course of a few hours. If all of a sudden it's, beating sun and that, now that piece of concrete's out in the sun, it's going to get hot pretty fast. So the surface exposed to the sun gets hot the quickest and therefore expands the most. And the surface that's in the shade or furthest away is going to expand the least or less quickly. So now you have a differential expansion rate, right? I'm getting to foam coring here. So in a lot of practices that people use is instead of casting a piece of concrete that's say 2 or 3 inches thick, because they want it to look massive, they want the strength of a full bottom tensile face and a full top face, but they don't want a solid piece of concrete because it weighs too much and it uses too much material. Is they'll embed a chunk of foam. So let's say this is a piece of foam, you basically have a shell of concrete around it. And that shell of concrete's usually 1/2 inch or 13 millimeters thick or thicker. If you completely encapsulate a piece of foam with very dense, impervious concrete, you've just made a concrete balloon. And what happens to a balloon when you blow air into it? It expands. So if you've got a foam core piece of concrete and you put it outside and that top surface gets hot, 2 things are going to happen. That top layer is going to expand from the heat. Now, foam is an insulating material. That's why it's used in insulation. So it is now a thermal barrier protecting that bottom layer, which is in the shade, from getting hot. So now you have a situation where part of your concrete is expanding, part of it's not. So it's naturally trying to expand and it's going to curl. And then that top's getting hot, but it's also heating up. Foam is mostly air, and gases expand when they get hot. And a hot gas in a sealed environment is going to create pressure, and that's going to start creating pressure and potentially cracking your concrete. So good practice is to drill vent holes on the underside that drill into the foam so that you alleviate that air pressure. Now, excellent practice is not to use any foam outside at all.
Years ago, I used to a lot, and I did one outdoor thing, and this is really, I had started doing vent holes, but I hadn't stopped foam coring, which I really have now. I don't do a ton of foam coring anymore, but I forgot to drill the holes at the shop. And so I got to the job site, I installed the job. It was, 100 degrees outside because it was Florida in the summer. And tops were light gray, but they were really hot. And I was like, oh, crud, I got to drill a hole. So I went and got my Tapcon bit, little, they don't need to be massive holes, small. And the first hole, I got through the concrete and I heard, psst.
Yeah. It's like punching a hole in your tire.
Yeah.
It's surprising how much pressure can build up. So there's a tip for you guys. If you are going to foam core, make sure you have vent holes on the underside of your concrete. Obviously you don't want them to be seen, and they only have to be 1/8 of an inch, maybe 1/4 of an inch. Nothing big, but don't just do one. Do, several to ventilate the pressure.
Oh, absolutely.
So that was kind of like a side note on that. But the other thing I wanted to talk about was, okay, let's say you're doing an outdoor kitchen and it's multiple pieces. So now you've got seams. Seams for outdoor concrete have to be treated differently than seams inside because of the expansion and contraction that occurs. And really what I'm getting at are 2 things: the size of the seam and what you put in it. Now, regular concrete, like a driveway concrete or whatever that has mostly rocks, has a thermal expansion coefficient, the rate at which it expands. It's just some number. I'm going to call it 1, right? It's some really small number. But what it means is you take the temperature of the concrete and the length of the piece of concrete, and that coefficient lets you predict how much that piece of concrete is going to grow or shrink. So if I, let's say with GFRC, and these are really, really round numbers, right? I'm approximating. If I have a 10-foot piece of concrete and that 10-foot piece of GFRC changes temperature by 100 degrees Fahrenheit, which is like between, winter and summer, easily, that concrete is going to grow or shrink, depending which way you go, by 1/10 of an inch. That's 2.5 millimeters.
It's almost
It's almost, yeah. So it's quite a bit, right? So if I have a 10-foot piece of concrete and I place it tightly between two other pieces of concrete, because that's how I do it in a kitchen inside, and I install that, say, in the springtime when it's like room temperature out. Now in the summer, when that sunlight comes on, so it's dark concrete, that concrete gets hot, it jumps up potentially. I've measured concrete outside that's a dark gray that's 160 degrees Fahrenheit. That's easy. So I could easily get 100 degree temperature change from when I installed it to peak summer temperatures. That concrete is now going to want to grow. And it's going to be tight up against concrete. So it's going to be fighting other concrete. Well, what's happening to the material in between that seam? It's getting squished. It's getting crushed.
Mm-hmm.
And now it's going to get squeezed out. Now go the other way. In the winter, it freezes. Everything shrinks. And so it's minus 20. Now that's an 80 degree temperature change from when I installed it. So now that concrete's going to shrink by almost 1/10 of an inch. And now that seam, which was tight, expands.
So really, the good rule of thumb should be a very stretchy seam material, silicone, something of that nature, and a larger seam. So an 1/8 of an inch seam in the summer would be ideal.
Well, here's how you've kind of figured that. This is getting a little mathy here. You look at the expansion rate or the stretchability, the elastic range of your sealant. So silicone is, I think, usually like 25 to 50%. Let's just pretend it's 25%.
There's a company called Big Stretch that I really like. Their caulk is very stretchy.
Yeah. So there's some stuff that's got like 150%. So it's very, very stretchy, right? So the more that product can stretch, the less problems you're going to have. Now, so let's work in really simple numbers here. If my seam will change by 1/10 of an inch, and my original gap, and my original seam was 1/10 of an inch wide, and I could have 1/10 of an inch change plus or minus, that means that seam can go to nothing, or it can go to 2/10 of an inch wide, right? So I now have, and so I'm growing, that seam is growing, that original 1/10 of an inch seam is going from 0 to 2/10 of an inch. That's 100% change. So that sealant has to be able to withstand 100% stretch. But even if it could do that, you can't have it go to nothing. So there has to be some allowance there. Now, if my original seam was 2/10 of an inch and it only changed by 1/10 of an inch, that's 50%. See where that comes in? So really, really big pieces are going to change more than smaller pieces, and larger gaps are going to change relative to their original length much smaller. So your seaming material isn't going to be affected. So it's when you have a really big seam with really tight joints is where you're going to have a problem. So you gotta pay attention to that. And a good rule of thumb is maybe an 1/8 inch. I'd be more comfortable with 3/16 of an inch, and then using a very, very stretchy material. And then keeping those seams pretty small. Don't do a 10-foot countertop. Yeah, the clients want it, but you're going to have seaming issues because that concrete's going to move. And the reason why GFRC, and I'm talking about GFRC, but it has nothing to do with the fibers. It's the base concrete mix design.
Heavy cement.
ECC, UHPC, all these are all under the same umbrella. Very high cement content mixes where you have relatively small amounts of aggregate. Aggregate expands and contracts a lot less than the cement paste. And when you have a lot of cement paste, the bulk matrix moves a lot more. So compared to regular concrete, like you pour a driveway, GFRC expands and contracts twice as much on average, twice as much. So it's just stuff to bear in mind. There's some rough rules of thumb, but just bear that in mind, because if you don't want to have a callback, you can't seam outdoor pieces exactly the same way you seam indoor kitchens with the same ingredients. You have to change things up.
So that was an hour and 20 minutes.
Yeah.
And I think that's a good stopping place, because we've given people a lot to think about.
Absolutely.
We have, and so and I'm going to try and do chapters on YouTube. We'll see. But, we've talked about, exterior countertops was the main focus, right? But we've talked about admixtures and polymer, curing practices, foam coring, sealer selection, seaming for exterior applications, how to avoid callbacks in general for exterior applications. So, yeah. So this has been a very, very packed episode. So, rewind, listen more, ask us questions. We've been receiving some comments on the YouTube channel, which has been fun. I would love to see some Q&A on the Spotify, app. I monitor those. So, if you're asking questions, you're going to most likely get me answering. So that's fun. And then reach out to us, info@concretecountertopinstitute.com with any questions. And again, plug, we've got classes coming up, August 7th through 11th. That one's coming up real fast. We're going to be doing, I think, some real world application projects. So doing maybe a real project at my house. So excited about that possibility. We've got a 2-day GFRC coming up November 9th and 10th, as well as an ultimate course, 5-day ultimate course, Elevate Your Business in 5 days, December 4th through 8th. And then be on the lookout as well for 2024 dates coming up. So a ton to think about, a ton to listen through, a ton to absorb and assimilate. Join us also on Facebook, Concrete Countertop Institute, of course. And we've got a Facebook group that is CCI alumni that you can join once you've come to one of our classes. Although I'm considering, maybe expanding that a little bit, maybe not. But we would love to see you on Facebook, Instagram, message us, and just be in touch with us. Contact us, email, Instagram, Facebook, podcast, YouTube, etc., etc., etc. So we want to be accessible to you to help guide you toward true success in the industry.
We're here for you.
That's exactly right.
We want to see you. Well, we want to hear from you. We want to engage with you. So thanks for joining us today. And we look forward to reading your comments, and stay tuned till next week.
Stay tuned. Have a good one.
Bye-bye.
Bye.
Thanks for listening to the Maker in the Mix podcast. If you liked the content and want to hear more, please like and subscribe. Feel free to follow us on YouTube as well as Instagram, Facebook, and check out the website, www.concretecountertopinstitute.com. And of course, we'd love to see you at one of our upcoming classes. Tune in next week for more informative content. Thanks.